Hi, good morning or good evening, everyone. This is Dr. Wei. Welcome to this class regarding to the changes of ASCE 716, which is adopted by IBC 2018. This class is talking about section 11.4 for determining seismic ground motions values. So comparing ASCE 710, this version has substantial changes. I hope this class could help you to understand this section better and maybe remove some confusions. So this slide will give you a typical approach to determine seismic nodes. So first, you need to get the map SS, a short period, and the S1 long period seismic parameters from the seismic map. So you can either use the maps in the IBC section 1613 or go to this website. This is a ASCE 7 header tour online website. It's designed to give the people can automatically determine the seismic load based on your location. You can either input the longitude, altitude, or your zip code or your address. You can get the SSS1 automatically. You need to pay that. It's about $60, but it's definitely worth because this tour not just give you seismic node, but also give you wind, slow rain, and tsunami nodes. So once you have the SS and S1, you need to determine the site class. So basically, the IBC referenced the chapter 20 of ASCE 716 for the site class. This is the same as the ASCE 710. So you need to do the site investigation to get the shear velocity or SPT M value or the cohesion of the clay. So I won't describe too much detail about that. So you use that, you can get a site class. Then you can, based on the table 1613.2.3, you can determine the site coefficient FA and FV. And you follow the code, the step, then you can get the ground surface MC level SMS and SM1. Then your design SDS, SD1 will be the 2/3 of the MC value. So once you have that, you can follow the approach in section 11.4.6. You can plot the design response spectrum. So this is a typical approach. The approach is still the same as before. However, the difference I will show you in next slide. So this is the example of ASCE 7 hazard tour. So basically, what I did, I just go to the Memphis city and I pick up a place. So it will automatically tell me the longitude and latitude, and I give a size risk category 3. The soil class I use D, stiff soil. So it will automatically calculate, get SSS1 and calculate FAFV based on the linear interpretation. Suppose you need to get SMS SM1, then the SDS SD1. However, as you can see, for the FV is blank, no value for that. So for that reason, you cannot calculate SM1 as D1. So basically, you cannot construct the design response spectrum for your base shear node calculation. So as highlighted in this red box, it indicates no seismic spectrum. And also, is you need to do the ground motion hazard analysis based on the section 11.4.8. So this will be the substantial change compared to 710 because we know for 710 for site class D, you can always get the design response spectrum. You don't have to do the uh, ground motion hazard analysis or site specific response analysis. So why there is substantial change, I will talk about in the following in the rest of class. So first, this slide just show you a table for the psi coefficient Fa. Compared to 710, it add one column for the SS greater than 1.5. So this is based on recent earthquakes. We have more large earthquakes than before. So they have this one column. At the same time, for a site class B, it used to be value 1, now it's changed to 0.9. The basis for this is the site class B is for shear wave velocity 2,500 feet per second to 5,000 feet per second. But for the site coefficient is based on a lot of site response analysis. The rock velocity actually are lower than the BC boundary uh, shear wave velocity. So when you convert to the site class B, so they actually you see some reduction for the loading. So this rad value indicate is there's some changes comparison from 710 to 716. So generally, we say the value are increase, which means you will have a higher seismic node. Another thing you can say is for the site class E, it is has same requirement as site class F. We know for site class F, you always need to do the site specific response analysis. So now they have the same kind of requirement for site class E when the SS greater or equal to 1.0. So what does that mean? I will talk about that later. And also another change is for the if you don't do any site investigation, you use default site class D. For the FA value, you have to use minimum value 1.2. As what we see here, when the SS greater than 1.0, the FA value is 1.1 or 1.0. So that means if you don't do the site investigation, there is a penalty. You could have a 10% to 20% high seismic loading if the project is located in high seismic zone. So this is about the site coefficient FV. This table is that used in the ASCE 716, which is also the table 13.2.32 in IBC 2018. But unlike the FA, for the FA, you know, the two code, they have identical tables. For this table, the table in IBC 2018, actually, they are a little bit different. I will talk about that later. So compared to the 710, here are the major difference. Again, it added one additional column for very large earthquake. And site class B used to be 1.0, now is reduced 0.8. Always remember, if you want to use a 0.8, also like FA table, you want to use 0.9. The code require you have to do the site specific velocity measurement to confirm the site class B. If you don't have this survey velocity measurement to confirm the rock, you have to use the value 1.0, same as 710. So the major difference here is for the psi class D and psi class E, when the S1 greater than 0.2, for psi class D it has a note A, and basically is a kind of same requirement as psi class E. It says see requirement for psi specific ground motions in section 11.4.8. So that means, here is some kind of confusion, based on low A, it appears you need to do the psi specific ground motion. However, they already provide FV value, you suppose can calculate the SD1. And in the IBC 2018, they also provide the values for psi class E. So there's some kind of difference with the ASCE 716. Actually, the supplemental of ASCE 716 will include this value. So here's some kind of confusion. With those values, you can calculate the SD1. So why do you still need to do the site-specific ground motion analysis? So that's something I want you guys pay attention in this class. So let's use the Memphis example. So you have the S1 value 0.309. So that's in this range, greater than S1.3, less than 0.4. So theoretically, you can do the linear interpretation to get FV, but you cannot do that. So that's the thing I want to emphasize in this class. So those values they provide here, they have some kind of special rhythm. You cannot use those values to calculate SD1 for the design. So you have to check the section 11.4.8 to figure out how to calculate SD1. Another thing is you see I provide a link here. So that's the IBC 2018 online version. Everybody can go there to check the code. So you don't have to buy the hard copy if you don't need. So, the table reference the section 11.4.8. So this slide just give you the entire section 11.4.8. So the section highlight on red, they are the new compared to the ASCE 710. So first, for structures on site class E with SS greater than or equal to 1.0. So you need to do the site specific response analysis or the ground motion hazard analysis. And same thing for structure on site class D and E with S1 greater than or equal to 0.2. You also need to consider the ground motion hazard analysis. Below that, it provides three exceptions. First is for the site class E, SS greater than or equal to 1.0. The exception 2 is for site class D, for S1 greater than or equal to 0.2. The exception 3 is for site class E with the S1 greater than or equal to 0.2. So the following slide, I will tell you what are the exception mean. So first talk about the exception 1. So it said the structures on site class E size with SS greater than or equal to 1.0. So provide the psi coefficient FA is taken as equal to that of psi class C. So in other words, if you are the project in a high seismic area, you're supposed to do the site-specific response analysis to determine the FV. If you don't want to do that, the code allow you use 1.2. So you use the value of psi class C, so basic is 1.2 here. So what does that mean? So if you look at the current ASCE 710, so for this area, FA is equal to 0.9. So now if you use the exception 1, you use 1.2. Theoretically, there is a 33% increase for your loading because we know that SS is used to determine the plateau of your design response spectrum. So if you follow the chapter 21, section 21.3, if you want to do the site-specific response analysis, the minimum FA can be taken as 80% of FA of 1.0 when the SS is greater or equal to 1.0. So in other words, if you do the site-specific response analysis, there is a potential the FA value could be reduced to 0.8. So you have to kind of compare the debate, the pros or cons, if you use the exception or you do the site response, site specific response analysis, because there is a huge difference for the node. So this slide is talking about for the exception 2, it's a little bit complicated. So first say, you have site class D and you have S1 greater than or equal to 0.2. So then you talk about when your structure period less or equal to 1.5 TS. So TS here. So TS is equal to the SD1 divided by the SDS. So this is the equation 12.8-2. So for this first part, it just say, you have to take this, basically this is the plateau value. You have to take this plateau value up to 1.5 TS. So your plateau doesn't end at TS. So now you have to extend to 1.5 TS. So the second part is for equation 12.8-3 and 12.8-4. So basically say for those equations, if you want to calculate the seismic response coefficient CS, you need to use 1.5 times SD1, or you need to apply the 1.5 factor here. So remember the R factor, the ductility factor and the importance factor, they won't change. So basically, you are talking about this design response spectrum. So for this part, is the SD1 value is not for the period 1.0 value, actually it's for 1.5 now. So eventually you will construct a design spectrum like this if you use the exception 2. So if you do the site-specific response analysis based on chapter 21, the green part, that will be the site response from the minimum response from the site response analysis. So what you can say, there is a huge difference in this period range for seismic loading. So if you see this figure, you have to consider, whether you need to use the exception 2 directly or you do the site-specific response analysis to reduce your node. Exception 3 is straightforward. So basically, if you are in this range, you have S1 greater or equal to 0.2, and if your structure period is less than or equal to TS, basically TS is the end point of your plateau. If your structure period at this site, you don't need to do the site-specific response analysis. You can still use the SDS to do your design. If you go back to the previous slide, you only need the equation 12.8.2 to determine your base shear. So if your structure period on the right hand side of this red line, so the site specific response analysis is mandatory. So this is the ASCE 716 table. If you look at this table, because the original table doesn't have the FV value, so in other words, you cannot calculate the SD1. So if you cannot calculate SD1, then you cannot calculate the TS. So basically, you cannot determine where is the boundary. You need to either run the site specific response analysis, or you can take the exception 3. So that's why in the IBC 2018, they put those value back. So those value can the same as the site class D value, the 2.2, 2.0. Those are used to calculate mainly used to calculate the TS. So you cannot use those values to calculate the SD1 for your design, but you can use this value to calculate the TS. Yeah, it's kind of confusing, but I say that again. So those values can only be used to calculate the TS. Those values cannot be used to calculate SD1. So now the question is, should I consider the site-specific response analysis or the ground motion hazard analysis? Well, first, you need to, based on your site class, and at the same time, if you are site class ABC, you don't need to do that. And also, if your project located in a low seismic area, you may not be consider that. So even you have the structure in the site class D and E, you can still take the exceptions to decide whether you need to do the site-specific response analysis. So for that reason, you have to have good understanding for the fundamental period of structure, but sometimes it's hard to determine that in the beginning of project, particularly you don't know what kind of foundation you will use. So for that, my recommendation is if you have a site class E located in a moderate seismic area, with S1 greater or equal to 0.2, my recommendation is always do the site-specific response analysis. Certainly, you need to consider who will pay, or if owner willing pay this additional analysis. Typically, it's about several thousand to maybe more than 10,000, depends on the complexity of your project. But you know, you should tell the owner, the client, you have this option as what I demonstrate in the previous slides. You do the site-specific response analysis. There is a potential you can substantially reduce the loading, which could be bring substantial saving for the project. That will definitely cover the cost for the analysis. So finally, maybe you need to consider sustainability. You know, if you do some advanced analysis, if you can substantially reduce the seismic loading, which means you have a less concrete or steel for the your projects, which means you will have less CO2 emission. So this is about this class about talk about the changes in the ASCE 716. I have a several following class talk, you know, kind of teach you how to do the site response analysis based on the chapter 21 of the ASCE 716. If you have any comments or question, please leave me a note. Thank you very much.